Welcome to another workshop in industrial automation. In this workshop, I'm going to cover this forward reverse motor starter. Basically, this is also known as reverse direct online starter. So this is a 3-hour workshop. You will be given a panel for wiring following a single line diagram. So you have to follow the laboratory safety rules. Do not bring any food or drink to the laboratory and report any hazardous materials. And when you do the practical, most important, and you have to disconnect the power before your control wiring. And once the wiring is done, it should be carefully checked by the instructor. Then only you are allowed to turn on the power. So in this workshop, the objective is create a single line diagram and perform the control and power wiring, which is an important thing when you go for industry. Often you are required to do panel wiring using contactors, relays, coils, as well as PLCs. So getting hands-on experience in panel wiring is a good practice, which we are trying to give in the university as close as to the industrial environment. For this workshop, you need to have 230-volt contactors and 2 auxiliary points, which going to be mounted on top of these contactors, because some contactors does not carry sufficient contact points. So we have to plug auxiliary contact points on top of the contactors. And 3-phase main circuit breaker, overload relay, 3-phase induction motor, normally open and normally close push buttons, and light indicators, basically yellow and 2 green line and 1 red lamp if required for indication purpose. In the procedure, you have to first disconnect the power from the AC mains, because the system runs with AC mains, and then you have to follow the single line diagram given in the lab. So once you complete your wiring diagram, you need to get your connection verified by the instructions. If the instructor verify it, then you are good to go. So in the observation, you need to attach a photograph of your wiring diagram, and you have to observe when the forward button is pressed, how the light indicators light up, and when the reverse button is pressed, how the reverse light indicator lights up. And since we cannot trigger an overload event, we have to manually trigger the overload relay, because in the real practical environment, we have to add some heavy loads on the motor, then it will drive large current, and then only the overload relay trips. But here there's an option for manual triggering the overload relay, so we are going to use that. So to simulate the event of overload and see how the fault light lights up. Finally, you need to explain how this forward reverse motor driver works with reference to the single line diagram provided. Before we start in the workshop, I would like to give you a recap of how a 3-phase induction motor direction is controlled. By looking at this diagram, you can see this is a 3-phase motor. We have 3-phase line into the motor, L1, L2, and L3. So assume this motor rotates in the clockwise direction. So if we want to rotate the motor in the anti-clockwise direction or to reverse the direction, what you can do is change any 2 lines in the 3-phase supply that is fed to the motor. Here, L2 is now connected to the terminal 3 of the motor, and L3 is connected to the terminal 1 of the motor. So that subs 2 terminals of the motor, which results change in the direction of the rotation of the motor. Similarly, you can do for any change to any 2 wires, then you can get the same result. Now, forward reverse motor starter, also known as the reverse DOL or the reverse direct online starter. Basically, you need to use two contactors. In the forward DOL, you just need to use a single contactor, but when it comes for reverse DOL, you need to have two contactors. And for the protection, you have the main circuit breaker, as well as for the protection of the motor, we have the overload relay. So take a look at this wiring diagram. So we have the three-phase line in, which goes to the main circuit breaker. So main circuit breaker is used for disconnecting the downstream devices. Sometimes it also offers overcurrent protection. Then it comes to the forward contactor, this one. So if you want to run the forward direction, so what you can do is turn on the forward contactor. So that will resource the current to flow to the motor and it will rotate in one direction. And if you want to change the direction, as I mentioned, you need to change two terminals of the motor. So this is how it is done using an additional contactor. We call it as a reverse contactor. Here you can see that the L1 phase comes to here and it is again goes back to the L1 of the motor. So this line is not changed. It is as same as the previous line. But you can closely observe that the yellow one, the L2 comes here and it is swapped to L3 of the motor. And the green one, L3, comes here. It is changed to now for the yellow color one or the L2 terminal. So L2 and L3 are now reverse connected to the motor terminals, which results the motor to rotate in the opposite direction. So this is the basic wiring diagram. It does not carry any additional features, for example, the interlocking, because you should never turn on the forward contactor and the reverse contactor at the same time, which will result short circuiting two terminals of the lines, which results large current to go through. Sometimes it could damage your protection devices. Sometimes it could damage the motor as well. So there should be some interlocking. So when the forward contactor is pressed, it should not allow the user to turn on the reverse contactor. For that, we can use either mechanical interlocks or you can use the electrical interlocks, or sometimes both are used. Now we are moving to the single line diagram. You can see here, so this is the power wiring and this is the control wiring. So three-phase supply is coming from these terminals and this is the neutral wire and this is the protective earth. So the protective earth is connected to the chassis of the motor. It does not go through any contact points. It is directly connected to the protective earth. So three-phase supply L2 and L1, L2 and L3 comes to the main circuit breaker and it goes to the forward contactor. So when the motor runs the forward direction, this terminal current will go just pass in the forward contactor, then it goes to the overload relay. So then it is connected to the motor. So in the event of overload, this will trip this contactor and protect the motor from large current going through and protect the motor coils overheating. Now let's see how this direction is changed. As you can see here, this L1 comes from here and it is connected to the W1 of the motor. L2 goes here and it is not changed. So the middle wire is not changed, right? You can see here it is comes through here, again goes back to the same as the forward contactor. But in the third one, the L3 comes here and it goes to the U1. So basically this one this wire and this wire are swapped in here to change the direction of the motor. So this is the basic power wiring, but we have to control these contactors using a control circuit. In our previous workshop, you have studied 24-volt contactors, but now we have all the contactors operate in using 230 volts direct supply. So you need to use one phase for that and the neutral. So here L1 phase is used. It doesn't matter which phase you're using. Either you can connect it to L2 or L3, but here L1 and the neutral is used. Again, for the protection of the control circuit, we need to use a circuit breaker or a fuse. But here we have used two-pole circuit breaker. Depending on the current rating of the system, you have to select it. Then it goes to the line, and this is the neutral. So neutral is common to all the contactors and light indicators. Now let's see, like this is the current from one phase goes to the overload. If there aren't any overload event, if this the motor is running in normal conditions, this normally closed contactor is closed. So it allows the current to flow through here. This is the stop push button. So normally it is not pressed until you want to stop the motor, then current comes to here. So assume that we want to start the motor in the forward direction. So we need to have a forward motor starter push button. So this is the starting momentary push button for the forward direction. When you press this path is now completed and goes through here. This is the KR, that is the reverse contactor, normally closed contactor, which means this has to be closed when this is not energized, which means you will never allow to turn on the forward contactor in the event when the reverse contactor is energized. So that is, we call it as interlock. So if the reverse contact is de-energized, this is closed, then only you are allowed to pass the current through here and energize the forward contactor. So once you press the forward contactor and the reverse contact is turned off, this KR, the normal closed contact is closed, and that will energize the forward contactor coil. So that will allow the auxiliary point 83 and 84 to this normally open contactor to close, and based on that the coil is latched. Even when you release the forward push button, this contactor coil is self latch using this KF1 auxiliary point. Now since KF1 is energized, the motor is running in the forward direction. So similarly, there's another auxiliary contactor normally open, which connected to 53 and 54 of the same contactor. So when this coil is energized, the power contacts close as well as this auxiliary contact close, that will illuminate the forward light indicator. So the operator can see that the motor is rotating in the forward direction and the forward light is lit. Now, if you want to rotate the motor in the reverse direction, you cannot press the reverse contactor. Even though if you press it, it will not allow the reverse contactor to energize, because this point is open now, because KF1 is energized, which leaves this normally open contactor to open. Even though you press this path is disconnected, that will not allow the reverse contactor to energize. So what we can do is we can stop the circuit, or you can reset the circuit to the normal position. Then this one, the forward contactor will be de-energized. Then you can press the reverse contactor turn on push button. So that will result again energizing the reverse contactor and the motor to run in the opposite direction. So when you energizing this, this coil reverse forward contactor has to be de-energized. When you reset it, it is already de-energized. That will result this KF normally close contactor to be closed when you start in the motor in the reverse direction. When the motor is running in the reverse direction, the reverse light indicator will lit based on the normally open contactor of the reverse contactor that is connected to 53 and 54 of this reverse contactor. Now, when you stop the motor, this one is de-energized, then the current will momentarily disconnect power to everything. In that case, when you just press and release this, so the power comes to here, both contactors are off. In that case, they are normally closed contactors, or the auxiliary point are connected here, and that will result the stop light to lit. So which means when you stop the whole circuit by pressing this one and release, normally the circuit in the red light is lit. So that is an indication the circuit is at stop position. So when the circuit is stopped, either you can press for forward or reverse. When it is running in the forward direction, you cannot run it press the reverse push button because this is interlock. Now assume like there's an overload event due to heavy loading of the motor. This overload may trigger. So in that case, the current comes here. This will trip, or then this normally open contactor will open. That will de-energize the all power to all the light indicators and the coils, power coils of the forward and reverse. But it will display the yellow lamp or the fault lamp to the user by using the normally open contact of this overload relay. So here there's a 11 and 12 is used for the auxiliary contact points for powering these indicators and the coils, but it's normally open contact of the relay is now used for the light indication using the yellow lamp. So if this is triggered, this one will be open and de-energize all the coils and lamps, but at the same time it will energize the normally it will close the normally open contact and light the yellow lamp. So unless you reset this overload relay or clear the fault and reset it, then only you can start the circuit again. So that is all about the control and power wiring of this reverse direct online starter, and we will see a short demonstration how this panel wiring is done at the lab. Here you can see the panel board in our mechatronics lab. Basically, you can have this momentary push buttons to turn on in the reverse direction and in the forward direction, and to stop the motor. So here we have this light indicators. When you turn on using the reverse push button, the green lamp for reverse running will light up, and for the forward running also we have another light indicator. When you stop the motor, by default it should looks like in this red color light comes up. In the event of a fault, this yellow lamp should light up. For example, our motor overload event, this forward light should indicate up. If there's a fault, you are not allowed to run the motor unless the fault is clear. As well as when you run the motor in the reverse direction, this reverse lamp should light up. And if you uh, press this forward button, it will not run the motor in the forward direction, because you have just learned there's an interlock. So what you have to, if you want to run them in the motor in the forward direction, you have to stop the motor, then click this one. So in the either way, whether the motor is running in the one direction, you have to stop it and then run in the opposite direction. Now you can see this panel wiring. Here, the main power comes in, three-phase power comes in, and that is wired to these terminals along with the protective earth. And the main power goes out from the power out, which is connected to the three-phase induction motor along with the protective earth. So the protective earth or the chassis of the motor comes here, and the panel chassis also connected to the protective earth, which all goes to the protective earth of the your panel wiring at the installation. When the main power comes, it directly goes to the three-phase main circuit breaker, where you can isolate or disconnect the power to the downstream devices. Another single-phase MCB is used to connect or disconnect the power to the control wiring. Sometimes you can use a single phase MCB or sometimes two-pole MCB if you want to isolate the neutral as well. But in this circuit, only the live terminal, one of the live wire from the three phase, is connected to the single phase MCB, and the neutral is directly coupled to the neutral. Here you can see the two contacts. This is a forward contactor. On top of that, there's an auxiliary contactor for additional normally open and normally closed contacts, which is used for light indicators. Because when you purchase a contactor, only few normally open and normally closed contacts comes up. But when you want to do additional wiring for indicators, you need to purchase this white color auxiliary contact points. Here you can see the reverse contactor, and it is auxiliary contact point. This is the thermal overload relay. If there's a thermal overcurrent event happens, this will disconnect the power to the power out terminal. You can manually trigger it, and this blue color one is to adjust the triggering current. So whether you can select it 2 ampere, 4 ampere, or 6 ampere, depending upon the selected thermal overload relay. So in this, the bottom side of the panel, we have this light indicators. This is for forward, stop and reverse, as well as your push buttons, momentary push buttons. Light indicators, four of them should couple to the neutral, and based on that, the other wirings goes to the your auxiliary contact points via this wire, PVC wire ducts. And the push buttons are also connected according to the wiring diagram given in your lab manual. So you are required to do the wiring from the scratch and complete the wiring and verify it by the instructor before powering it up. So here you will learn, you have to carefully investigate the current ratings of this three-phase MCB and the current ratings of the thermal overload relay and auxiliary contacts and their numbers, and how you can wiring them according to the single line diagram given in the lab manual. So now when you go to the lab, you can complete the wiring and learn more about the panel wirings. So that is all about this reverse direct online starter workshop. So you will gain more knowledge on panel wiring, which will be helpful you for when you practice in the industry. Now you can see the demonstration of reverse DOL. First, when we press the forward button, it will go to the forward, and we have to stop the motor, then go to the reverse, and then go back to the stop. So it is not allowed to reverse run when forward is running. The only thing, you have to stop it and go to the other direction. So we can see the fault by manual triggering of the overload. So there's a overload trigger. We have to press it, so that will um, enable the overload relay, and the fault light will light up. Then we have to reset the system or reset the overload relay. Then only you can go back to the initial state or the stop position of the motor.